Okay. Okay. Okay, guys. My screen is visible, right? Online team, anyone please can confirm? My screen is visible. Thanks. Okay. Okay, guys. So I'm going to discuss project. Okay. Let's move to GitHub repository. Yeah. So guys, same. This project is contains 3 layers: front end and back end and DB. I'm going to give task to you. Don't worry. This project, what you need to do. Okay. Now you are not freshers, right? You are not freshers. Okay. So this project database is required. RDS. Okay. And back end, front end. So DB on pod, DB on container, DB directly taking RDS. Already we discussed, right? So if I take RDS, this is completely microservices project. So everything deploy inside the pod. But DB, I'm not taking containerization platform. Directly taking RDS. Kubernetes time already clearly explained, right? If you take DB on pod, we have to take care of many things. Storage, yes, definitely we have to take storage. But here also we have to handle storage. Even we are not taking DB on pod also for logs purpose, Elasticsearch, we need a storage. It's a different story. For application point of view, if I take a RDS, so our job is easy. For the backup point of view, read replica point of view, storage point of view, whatever it is. If I take DB on pod, definitely I have to take a EBS or EFS volume additionally. Plus, we have to write a sync rules, read to master, and we have to use the stateful set. And then again, we have to use for headless service. This is we have to use for the DB on pod. Okay. If I take RDS, so we no need to use these many things. Simply RDS, that's it, leave it. And coming to the backend is Python, front end also Python. So my backend is connected to database, front end is connected to my backend server. Here, if you can see, a backend having a app.py, it's a common app.py, logical layer. And coming to the front end, we have many microservices are there. Computers, earphones, electronics, Google clothing, groceries, music, Google Play. What is main here? User interface. From here only request will go to these paths. So in Ingress controller project, we discuss AWS, Azure, GCP path, right? So this main is a path where user will interact. So this is the load balancer here. Ingress controller means not load balancer. This Ingress controller redirecting into computers path, earphones path, electronics path. These many paths we have to create. Clear na? I'm not going to explain what is Ingress again. How to create Ingress ML, how to create deployment.ml and all. Okay. Okay. So the same project we can implement Grafana Prometheus. In same project we can implement UFK stack also. EFK stack means, so Grafana Prometheus will give the metrics, not about the logs. Success logs, failure logs, error logs, whatever it is. Grafana will not show. Grafana also will show if you integrate Loki, right? In the observability stack time already discussed, right? Loki concept. Single dashboard for metrics, single dashboard for logs, single dashboard for traces. So, but this is different tools, different experience. Okay. Instead of using Grafana Prometheus, we can use a Kibana. Kibana is a monitoring tool. And E means Elasticsearch, where we can store the logs. Fluentbit, collector, log collectors from the each node and each pod also. Clear now? So node exporter is there now for the Grafana. Prometheus. Node exporter collect the metrics from the all nodes and give to Prometheus. Here Fluentbit is the responsible for collect the logs from the each pod, each node and give to Elasticsearch. Elasticsearch store the logs. And Kibana get the logs from Elasticsearch to show last 1 year logs, 1 month logs, 2 months log. If you want to perform 1 month logs, 2 months logs, definitely database required to store the logs, right? That's what Elasticsearch. EFK I can deploy through Kubernetes. Elasticsearch image I can take, Fluentbit image I can take, Kibana image I can take. Elasticsearch is a database, right? So definitely we can use EBS drive to store the logs, not node. So volumes we can create additional volumes, we can create external volumes, internal volumes. External volumes, whether you can use EBS or EFS. Internal volume, host, node port, node path. So definitely Elasticsearch means a database. I need to deploy inside the cluster. If multiple replicas are there, definitely go for stateful set. Clear or not? So definitely EFK stack, if you click on it, these are the many files are there. Okay. Config map, service, secret, service. These are all already we discussed concepts only. Not even single concept, you know, every concept you know here. If you open and all, AML file you can understand. For example, Elasticsearch service. Elasticsearch STS means what here? Stateful set. Everything discussed one only. So stateful set. Here I'm taking a 3 replicas. Elasticsearch image I'm taking here. Okay. So you can see volume I'm taking a PVC to connect the volume templates and all. So Elasticsearch is required, right? Which service this is? Cluster IP equal to none, headless service. Same thing you can go for storage class. This is for create a storage class for EBS volume. So if I want to run EFK stack, I need a definitely Elasticsearch deployment.ml, but we are using Elasticsearch as a database. We are using a stateful set.ml. We need a Fluentbit. Fluentbit we are using to collect the metrics. So Fluentbit is required. And next is what? Okay, you tell me guys, Fluentbit we can deploy which YAML file? Fluentbit we can use for which type of YAML file? Very good. Daemon set. I will discuss daemon set, right? So daemon set will deploy your pod. See, Fluentbit also deploy as a pod, right? Fluentbit process run as a pod inside the cluster. The pod should run each node or not? If scheduler don't know, right? Scheduler by default process is what number of resources available. It will schedule the pod. But I want Fluentbit collect the logs from each and every node and each and every pod. So Fluentbit podcast should run each node or not? Daemon set. That's what Fluentbit daemon set. Clear or not? And next is what? Kibana. Kibana is what? Just a monitoring agent. Can deploy through deployment.ml or stateful set.ml. Kibana is a dashboard only. Stateless or stateful? Stateless. User interface only. So I can create through deployment.ml, right? Deployment.ml. Kibana. So service, cluster IP or node port, your wish. Load balance also you can use. Clear not till here? EFK stack. Okay. Next. Go to front end. So we have a multiple applications, computers and earphones. Each application we have a Docker file. So this is a process. Deployment.ml. Everything is there. Same thing here. Earphones, electronics, Google clothing, groceries, music, Google Play. Main will call all the number of services. Clear na? So when you use, definitely you can see this main contains all entries, right? Your all paths, Google. So Google clothing, micros. So let's click on this. You can see here. So we are calling a different one, right? So we are calling it here Google clothing, music. You can see here different everything, all whatever paths are there here exist everything here. Okay. Yeah. Clear now? Yeah. So in this case, first what I need to do, guys, here, I need to build multiple images. Front and main image, back end image, multiple service. See, each service inside one Docker file there are not there. So I need to build these many images first. So these images I can push into ECR. From there, I can deploy into where Kubernetes files. Kubernetes files, see, you can see here. Kubernetes files are there in K8s Argo CD here, front end. So if I apply front end, all YAMLs will be applied. If I apply backend YAML will apply. If I apply EFK stack, all EFK stacks will apply. EFK stack, I'm calling EFK path. EFK stack contains these many YAMLs. You can add directly YAMLs also, or create one YAML file to call all EFK stack files. Clear na? So this is usually we can do Argo CD inside create application, give the path, right? Or you can create Argo CD application through YAML also, right? I have discussed two approaches. Through YAML you can create application, or manually you can create. So these and all we are creating through YAML only, not manually. Clear na? Okay. So Grafana Prometheus, only two commands directly we can run: Grafana installation, Prometheus installation. Clear na? So for this process, by using Terraform, we can create infrastructure, VPC, subnets and everything. And we can create RDS, we can create a cluster also. Clear na? So my end already have created RDS and cluster also readily. So I can start the process directly. Okay. So first, this is my client node. So today your job is understand the project, prepare one document. Understand? So the document is you have to prepare in an interview. Definitely this question is common. Explain about your project. Prepare the document how to explain the project first. Clear? So if you want to prepare a document, first you should understand the project. Not for code level, configuration level. Clear now? GitHub Actions I'm using. GitHub Actions YAML file you have to understand first. Kubernetes YAMLs understand. Docker file understand. Terraform code understand. Cluster behavior you should understand. And inside cluster services, process, stateful set deployment. These are our areas, not code. Clear now? Clear? So kubectl. Yeah. So 6 clusters are ready. You can also prepare one project. Many people are Java background, Python background, Node.js background, developers only, right? Why can't you build a one code for the good project? So this code, 9am batch person only develop this code. We have integrated at these many automations, but the code reference we have taken from the 9am batch person. You can also give any code. Yeah. Okay. So nodes are ready, right? So 6 nodes are there. Minimum you can take 2 nodes also, but high configuration nodes you have to take if 2 nodes. So I have taken 6 nodes. The first point you have to understand, for EFK stack, I'm using EBS volume. In this case, cluster level, you have to run add-on to add a EBS ESA drive. This is point number 1. Let's go to the cluster. Click on the cluster, add on. So get more add-ons. EBS CSA driver. Why I'm taking EBS? Somewhere we are using EBS volume to store the data. Okay. So RDS is not using. RDS is not using any EBS CSA driver. RDS separately I'm taking. Which concept is using Elasticsearch? In your project, how many database you are running? Two databases. One is for application purpose, one is for logs purpose. Logs purpose, taking Elasticsearch, I'm not taking directly from the cloud. I'm taking as a containerization platform. So definitely storage required, stateful set required, headless service required. Clear na? EBS CSA driver. Next. So you have to attach a IAM role. So mine all the role also ready. Next. You can create role if does not exist. Okay. EBS CSA driver is creating mode. Okay, leave it. We can check later. This is still creating, right? We can focus on different area now. Meanwhile, clear not till here. And let's go to RDS. So you can come up with the more ideas now. This project still we can add anything. Understand? Database created. I'm taking the database endpoint here. So my backend code is there now. My backend code inside app.py inside. I'm just giving a host. Clear now? So username password I have given same thing only. Commit the changes. Okay, ignore. So this is connectivity for backend to RDS. Clear now, guys? Okay. Now we can start. This is first two entries we have to do. Backend deployment, RDS endpoint, and now EBS CSA drive enable. After complete these two tasks, so required dependencies you can run inside your EKS, kubectl installation, EKSCTL installation, and Helm installation. Okay, whatever. Ingress controller, if you want to install Helm is required, Helm installation. Whatever dependencies required, you can do. So we have added everything here, guys. Readme.md file. In single place, we can collect everything. Install EKSCTL and create a cluster also if CLI support or take Terraform help. And install kubectl to run kubectl commands and install Git to clone the repository, source code repository. And next, Ingress. Ingress controller required or not? Multiple parts are there. AWS load balancer is a L4 load balancer by default created service. That load balancer not support multiple paths. It's a kind of network load balancer. So we need a path-based routing. So as we discussed in Kubernetes concept, Ingress, we should configure Ingress controller. Clear na? So I'm installing now. Ingress process. So it's creating. And I'm installing MariaDB for what? Initialize the DB. Database I should create, right? Initialize the DB. So to connect and run. So I can connect to RDS and run the required script first, or directly I can execute this one. Okay. So DB name, DB columns we should create now. These are the project related columns. Okay. And in this case, MySQL -h. So host name is what? -u admin. Backend.py, app.py. So admin and password is cloud123 I have given. Okay. Let's execute the initialization process. Required columns and table. Clear na? Very okay. So DB created, columns also created. So exit from here, Control D, exit. Okay, done. So now you can run any dependencies are required here. So Argo CD is required now. So CD process we are using. CI we are using GitHub Actions, not Jenkins. Okay. Argo CD namespace creating inside the Argo CD namespace. I'm deploying this Argo CD controller. So I'm creating a Google namespace for what? My deployment will run inside the Google namespace. Done. Now Argo CD password required, right? While accessing time. So I'm running this password. So this is the password to log in Argo CD. Okay. Yeah. Copy. Next. Yeah. So now you can check kubectl get svc -n Argo CD, right? Sorry. So take this load balancer and access UI for the Argo CD. Clear na? Copy. Password is decoded, right? Already. This is the one. Okay. Admin Argo CD ready. Clear na? So you can install Grafana Prometheus also. Now, if you required, you can install Grafana Prometheus also. So Grafana Prometheus separately I have given here. Okay. You can follow these steps for the Grafana Prometheus also. Clear na? So once you run, okay, later we can deploy, no problem. After deploy the project, we can deploy also this one. Till here, clear everyone? Okay. So let's clone the repository. Okay, guys. ls. So now this process, guys, first we have to deploy a backend. Clear na? When you deploy backend, load balancer will create. Take that load balancer and give into front end inside. Main.index.html is there, na? There. So front and backend will communicate. Backend already given RDS, 3 will be communicated. Clear na? Okay. So in this case, if you go to actions, already 7 minutes ago, backend is running. Why? The GitHub actions I have given, if you do any changes, automatically run. Push changes. So backend, I did some change, right? What change? RDS endpoint, I have updated. So backend executed. Okay. So in this case, I'm going to deploy backend AMLs, right or not? So let's check now. Here, easier part also I'm handling through GitHub actions only. Easier part also I'm handling through GitHub action. GitHub action itself will create a easier repositories. Clear now? And push the image also here only. So now you can see the AS 2320, just 2320 UTC. Okay. Let's delete this all. You can delete also, no problem, or it will create automatically. So the reason I will show you GitHub Action inside, I'm using a hash code process. Every runtime based on the timestamp changes, one ID will be generated. Based, I will show. Now you can click on it. You can see the image is okay. See, created 1036. Image has pushed already, right? So why backend AML, backend GitHub Actions executed? The reason I have done some changes in the backend inside. So backend will be executed, update this ECR images repositories. Okay, I'll explain the GitHub Actions time. Leave it. Now, image is ready, right? If image is ready, what I need to do? Update this images into AML file inside. Let's go to AML file. First, we can go for backend AML file. So guys, backend deployment at AML. You can see this is also updated. From where? ECR image. You can see 8 minutes ago. Pipeline executed, right? If you do any change, automatically run, right? Backend image update or not? If image is there, can I run deployment? How to run deployment? Using Argo CD. I'm not running kubectl apply and deployment. In this case, what I'm going to do? K's Argo CD deployment, right? Everything. LS. So my end backend is there, front end is there, EK stack is there. If you run backend deployment will be executed. So kubectl apply -f backend. So I should go to backend directory first. Kubectl apply -f backend. Clear na? ls kubectl apply -f backend.aml. Created, right? Can I check in application here? Clear or not? Backend created sync also. So this process you can create through like this also, right? New app, you can give a path and all, right? But I have given everything inside the YAML file only. You can check here. Cat. Clear na? Namespace Argo CD. This is the repo URL. Which namespace it has to deploy? Google. Which path? Backend. Clear or not? So my backend inside, my deployment.yaml is there. It is going to apply. I'm orchestrating from Argo CD. Path I'm giving and orchestrating from the Argo CD. Clear na now? So backend deployment is done. You can see, cancel this. You can run. So pods are running. So 2 pods are running. Even backend 1 pod fail also. No need to worry. 1 more pod is running. You can increase the number of replicas also. Clear na? High availability. Click on the backend service. So this is the backend service. Copy. Where I can use this? Backend load balancer. Where I can use? Front end. Let's go to front end. Same like that project. Ingress project I have discussed, right? Front end. Main. Index.html. Yeah, see? Sign up time, login time. See, only UI it will show sign up and login. If you click on the front end UI sign up and login, this is redirecting into target, right or not? That's what. Okay, so what I need to do? Line number 711, 712. Commit. Yeah, 711. Clear na? Here also API login. Clear na guys? Now, if I commit, automatically pipeline again runs or not? Now front-end image contains backend load balancer URLs. Otherwise, old image contains old URL, right? So again, it has to be run. Now you can see whenever you can push. See, update index.html, right? Again, pipeline is running. This pipeline is common for front-end and backend. Okay. So meanwhile, you can check this application. So only backend is running. You can see this one application running synced. This is one cluster, one namespace inside only running. So can I check meanwhile this EBS completed or not? Refresh. Eight before 7 active. So EFK stack also we can run. Okay. Still it is running. Once it is success, then we can apply front-end YAMLs also. Image should update, right? So you can go and check here. See, deployment.yaml is updated now. Image. And here, earphones also. 22596 updated. So every microservice inside, new image will be updated. So this complete process taken care by GitHub Actions only. Yes. The reason, let me show you that part also. I'll explain this process later. In security, settings, here I have given secrets and variables actions. I have integrated my access key ID, account ID, secret access key, git pat. Pat token is there now. So your end, what you need to do? Give your access key ID. Why access key ID, secret key ID? ECR repository inside you should create ECR repositories, right? For that. So GitHub token for what? Push the image from ECR to GitHub Actions. Done. This is also done, right? So now, okay. Can I execute now new YAML files? So images updated, right? All. So I need to run new YAML files. Clear na? kubectl. Okay. Git pull. Otherwise it will apply old one, right? kubectl apply -f dot. Clear na? Done or not? So now, okay. So what you need to do now? Let's go to Argo CD, refresh. Front end also done. But along with the front end, you can see all are different YAMLs, different paths, right? Why it's updating different? My GitHub, if you can see, my front end inside, multiple directories are there. Each directory inside, AML is there. If you add all AMLs, it will consider a single application. Clear or not? So multiple folders inside. So each folder, I'm calling different application. That's what Argo is inside. You can see these many things. Now you can click on it. Summary. Total 10 applications running. So sync 10 synced and namespace is Argo CD. Clear na? Go to front end. Front end where I can check? Front end main. Very good. Front end main. This is only the ingress path, main root path, right? / path. Where to go? Main service. This is main one. Copy. Okay. So I'm able to access. So these are the microservices are running electronics, phones, computers, earphones, pay, fashion, groceries, music. Okay. You can give sign up any name your wish. User registered successfully. Okay. Now I can see my account. This is now. So you can see browse phones, for example, Pixel, shop now. Why this is? Let's wait and go and check now. So which path pods are running? Kubectl get pods. iPhone, iPhone and Google. All pods are running. Phones, backend, computer, Google Play, and everything is running. Okay. So front end, backend path. Okay. Okay. So the issue is pods are running service issue. Okay. ls cd backend git. So we have done change into where? Git pull. cd backend. Let's check app.py inside. Correct host only, right? Admin. Okay, I'll do one thing is, let's go to backend deployment.yaml. Okay, let's go and check this is latest image or not. in ECR. One, two, three. Okay, okay, okay. 1055, right? 7EB0A. Correct only, right? 909A. This image only. Again, let's try. Okay, we'll do one thing. Let's go to backend app.py. Let's go to all traffic. Yeah, all traffic enable. Let's go and check Argo CD. I'll do one thing. Let's backend. Argo CD. Front and main. Let me check. Main service. Copy. Okay. So main service is working fine. If I give here, for example, okay, phones. It is taking phones path, right? So phones path not redirecting into phones application. Okay. So it's a common load balancer is what here? Backend load balancer, right or not? Okay. Let's go to check now. kubectl get svc hyphen n ingress. Sorry. Hyphen n Google. Okay. So main service running perfectly. Okay. Okay. Let's check kubectl get ingress hyphen n Google. Okay. Copy. Let's give for example. Okay. Okay. So let's go to Pixel Buds. You can click here, add into the shopping cart. You can open here. So checkout. You can scan this. You can proceed to buy a product. Okay, scan it. You will get. Redirect image, right? Yeah. So clear? Huh? You can click on fashion also. You can see. You can check Instagram reels also. You can see my reel. Okay. Like this, you can add anything. Promotion, guys. Application inside promotion. Yeah. So like this. So now each service running is a different pod, right? So now you can see kubectl, get pods, -n, Google. So now you can see all are not running a standalone application here. You have to understand that. Computers running is a separate service. Earphones, separate service. Electronics, fashion, Google Music, all are running separate services. Understand? Like e-commerce website. If something earphones application maybe fail, remaining still run, right? That path only does not exist. Remaining still it works. Clear na? Let's go for EFK stack also. Grafana Prometheus also we can do. Go to Grafana Prometheus. So I'm going to run Grafana Prometheus. Okay, guys. Grafana Prometheus also done. You can get the secret. So this is the Prometheus Grafana password. You know how to log in, right? kubectl. You can take here. Get pods. Service, right? -n Prometheus. So Grafana Prometheus is running into this namespace. Take Grafana with node port 30480. kubectl get nodes -o wide. Take any one of the external IP service, right? This is so anyone you can take, even node port also. What is the port number of Grafana? Port number 30480. I have taken private IP. Yeah. Sorry. Oh, okay. Admin, take the password here. This is the one password. Okay, decode password. Password is wrong. Let's run again that command. Copy. Grafana also. Prometheus also ready. Go to dashboards. You know how to create dashboard also. I have discussed it, right? Let's go for import 1860. Oh, import. These are the total nodes. You can select last 5 minutes. You can see the pods memory also. Okay. Grafana Prometheus configuration. Clear now? Next is what? Logs. Go to Google project again. CD EFK stack. Okay. Okay. These MLs you can apply from here or go to Kates Argo CD. Here also EFK application ML is there. Argo CD application ML to call these many MLs. EFK stack. This EFK ML not contains any deployment ML and all. This is to create a Argo CD inside. So this ML is create application call all EFK MLs. Clear now? So ls kubectl apply -f efk.ml. EFK stack created. So now you can check kubectl get pods -n Google. Kubectl get pods. Okay, let's. Huh? That's what I'm checking. Kubectl get ns. What is the namespace? Cubes. Okay, default namespace. If I'm not giving. Okay. Okay, let's go and check this ML. Cat. Maybe. Even you can check from here also. Argo seed inside may be deployed, right? You can check. EFK stack is progressing, still creating. That's what pods we are. Which namespace? Cube logging namespace. Clear now? Wait till complete the EFK stack also. So Elasticsearch, Fluentbit, Kibana. Now you can see Kibana pods are Elasticsearch pods are creating. And which ML? Stateful set. Volume should create, everything should create. See, Elasticsearch cluster 0 creating, 1 creating, 2 creating. It's following the sequence, right? Because of stateful set. Yes. And Elasticsearch request will come from where? Fluentbit. So Fluentbit will communicate Elasticsearch which service? headless service. Clear na? Readers. Kibana process the logs. It's a read. Understand or not? Kibana, if you open a Kibana dashboard, check the logs are a read request, not write request. Fluent bit requests are write request. So fluent bit request will go to 0 because of headless service. And Kibana requests are 1 and 2 because of reader request. So little advanced level, you have to understand. Clear till here? Okay. So this is also done. Now how to access? Go to Kibana service. Service. Yeah, Kibana. Kibana is a dashboard, UI, like a Splunk, like a Grafana. Node port we have taken. Okay. So Kibana port number is what here? Here only there. Node port. Okay. Namespace is cube logging. Okay. Copy. Even you can find here also port number. Node port. 3 to 4 to 5. Okay. Copy. So 3 to 4 to 5. So create index pattern, all type of logs. Select the timestamp, create index pattern. Yes. Now go to discover. You can see the logs. This is EFK stack. So end-to-end project, including logs, metrics, stateful set, deployment, cluster IP service, ingress service, load balancer service, headless service, VPC, subnet, EBS, RDS, load balancer, auto scaling, GitHub Actions, ECR. What we can add out, still, can we add anything in this project? That's you have to say now. What we can implement on top of it? Huh? Very good. Grafana alerting. PagerDuty we can configure. Alerting system. What about online? Can we implement any different service to do some activity on top of it? Any service can we add here? Terraform also we are adding to create a cluster. Very good. RDS proxy we can use. RDS read replica we can create. RDS I'm creating only standalone database. Next, Elasticsearch we can create for RDS to get frequent data. Next, front end I can use CloudFront service for low latency. I can use Route 53 to configure load balancer. Next, I can create a certificate manager to access HTTPS request. Next, I can create a S3 to take a backup of the any logs. I can create a Lambda function to take the backup of the logs from anywhere. Next, you have to say your experience now. Very good. SonarQube for scan the image. Already have added anyway. Not SonarQube, ECR scanner I have enabled. Jenkins CI/CD. Okay. See, I'm not asking alternate tools. Already GitHub Actions we are using, right? Can we add any other services for this project? I'm asking. Pods only, not nodes. Grafana, right? We can see nodes also. But yeah, correct. For example, 5 nodes are there as of now. Node level, if anything, if you want to configure, but this Grafana is both can monitoring. See, this is node metrics plus pod metrics also. In this case, for the metrics point of view, Ansible not required. For different point of view, all nodes we need the same configurations. But anyway, all nodes having a same configuration demonstrate will replace Ansible, right? Right or not? Yeah. Next. Very good, Akash. Probes. We can configure probes for health checks. Right or not? Each service we can enable probes. Next. You can say Kubernetes concepts, Terraform concepts, anything you can say. SonarQube also, right? Any other services? Very good. Ingress host path. Ingress host path, if you configure, we are able to access through host only, not through load balancer. Next. Next. Any other? So all are running a multiple applications. Any other services? In Kubernetes we can use. Yeah, Ansible. We can create a user. Yeah, very good, Palas. We can create RBAC, right? For what? Service account. Yes, we can add a service account in this project. So this is what you need to think, guys, in your interview to explain the things. So today your task is understand the project. I'm not explaining in detail. Understand. You know Kubernetes, you know Docker, you know easier, you know GitHub Actions. I want to, yeah, very good, Vinayak. WAF. This is very important service for the microservices especially. If any number of requests are hitting continuously for the span of 1 minute and all, we can block that IP. Rate limit, right? We can add rate limit. WAF, Route 53, Lambda, CloudFront. Yes, very good. This is what I'm expecting from you all. Anyway, so today your task is, you can try, maybe if you get any errors, nothing to worry. First, understanding is very important. Flow is very important. Prepare a flow, prepare a document. It will take 3 days, 4 days also, no problem. If you consider this is our main project, for example, 3, 4, 1 week also, no problem. Get a clarity clearly. You have to explain this project into your real time. Okay. So this is the repository as of now, public only. So any questions from anyone? Any questions from anyone? Okay, then start your process. So tomorrow, be ready for explanation of the project. Okay, or you can try today, tomorrow also take time, day after tomorrow. Okay, you can prepare like you have an interview how to explain this project. Otherwise, I can't do anything, you can't do anything. Thank you guys. Bye.